Combustion is a type of chemical reaction and it's a form of an oxidizing reaction because all combustion reactions require oxygen. So if oxygen is not present, combustion will not occur. When we talk about combustion, we talk about this triangle of fire. So we have this idea that three things need to be present when we're talking about any type of combustion. And when we think about combustion, we automatically think about fire. So if something is going to combust, three different aspects need to be present for this combustion reaction to occur. The first one is the idea of an oxidizing reagent. When we see the word oxidizing agent, we automatically think of oxygen, okay? The most common type of oxidizing agent is oxygen. And we know that if we remove oxygen from a burning fire, the fire will go out. Case in point, when you put the lid on a jar candle, the candle eventually goes out, and it goes out quite quickly because all of the oxygen is burned up in that little closed environment. The second thing we need is fuel. When we think of fuel, we always think of something like gasoline. Gasoline is not necessarily the only type of fuel out there. Fuel is anything that can burn. Okay, whether it's wood or plastic or clothing or gasoline, okay? There are a variety of fuels out there. And the whole point of a fuel is that it is a specific substance that's going to release a lot of energy when it reacts with that oxidizing agent, okay? And that third type or that third important ingredient in this triangle of fire is the ignition temperature. Now, the ignition temperature is kind of it's the one that's not really visible, okay? Like you can see when there's no oxygen left and a candle goes out. Although you can't really see oxygen in the air, you can actually see the absence of what oxygen does to a fire. You can also see when a fuel is no longer there. Okay, if there's no more wood left to burn, the fire's going to go out. Case in point, if you have a fireplace, and you put wood in the fireplace before you go to bed, so you keep the fire going overnight, when you wake up, that fire's not really burning anymore because it's gone through all of its fuel. But ignition temperature is not necessarily something we can see. Okay, ignition temperature is that lowest amount, that lowest temperature where there's enough energy that's present in order to start combustion. Okay, and I realize that that's pretty vague, but different ignition temperatures are going to vary for different types of fuels. Okay, some fuels have really high ignition temperatures. Depending on the situation, some fuels have really low ignition temperatures. The drier a fuel is, the lower the ignition temperature it requires. Case in point, if you've got wood and you're trying to burn it, if the wood is dry, that fire will catch and that wood will burn. But if that wood is wet, it will take a really long time to get that fire going, and you'll in turn create a lot more smoke. And that smoke is actually not necessarily carbon dioxide. It's actually a lot of steam as the water's being burnt off. So when we talk about combustion, we're going to talk about different types of combustion. We automatically assume when we think combustion, we think fire. Fire is a rapid form of combustion. Okay, it's basically, it's the most whiz-bang type of combustion there is because there's a lot happening in a very short amount of time. Okay, and the reason that a lot happens in rapid combustion is that this huge amount of energy, all right, is basically given off in the form of heat and light. So it really is eye-catching. It's not, but it doesn't last very long. Okay? Now, another form of rapid combustion is the idea of spontaneous combustion. Now, spontaneous combustion happens when a fuel is going to reach its ignition temperature, and it's not necessarily a fire or something being lit. Okay? And we see this happening in nature quite a bit. We see things like really, really dry seasons in the summer. We'll often see things like forest fires spring up. And if you go camping in national parks or provincial parks, you might not be allowed to light a fire because the area is so dry and the ignition temperature is so low that it's not going to take much to start that fire. Okay? So spontaneous combustion is when that fuel reaches that certain, it's kind of its threshold temperature, and it's just like, all right, I am so hot right now, I'm just going to combust. And it does happen. All right? We see examples of that all the time. And the one that actually doesn't get a lot of hype, all right, is the one that is most common, really. We see examples of slow combustion around us, all the time. The perfect example of slow combustion is something rusting. Okay? My car outside got a chip in it, and over time, that the actual steel of my car, or the metal that they used to make the hood, was exposed to moisture. And what ended up happening there is that really top layer of material was interacting with the moisture in the air and the oxygen, and it was rusting. And rust is a chemical reaction. There's no takebacks. Okay, when you bring a car into the shop to get rid of rust, what they have to actually do is sand off the rust on the car to expose new metal to the oxygen. And then they usually repaint that to protect it from oxidizing or slowly combusting. Okay? Cellular respiration is another type of slow combustion. And we know that cellular respiration happens in all complex living organisms. And that is an organism's ability to take sugar or glucose and react it with oxygen to give rise to carbon dioxide, water, and usable energy. Okay? Now, notice how the usable energy is in the equation, but it's not actually really a quantitative substance. So in reality, cellular respiration here, and this is not balanced by any stretch, but cellular respiration is a slow form of combustion. It's basically taking the fuel that we consume in the form of food, and it's using oxygen in the mitochondria to break apart those sugar molecules to release energy. Photosynthesis, on the other hand, is the antithesis of cellular respiration in that it's the opposite. Photosynthesis is not a form of combustion, but it is often lumped in with cellular respiration because it takes the products of cellular respiration and it kind of uses those as its reactants. It's kind of an opposite form of an equation. So here we have CO2 plus H2O, again, not balanced. Okay, and these two in the presence of sunlight are going to create glucose, and they're also going to create oxygen. Now, this only occurs in the presence of sunlight, which is radiant energy. So in both cases, we have forms of energy being utilized or produced.